here?
Yes, ma'am. Here.
Fine. The last one I have to fill. Well, is this? This is the one you are talking about? Okay.
Ma'am,
Do you understand? Yes?
in this 1.4 meter per second is not the correct answer. Like at least
No,
I
the
didn't get.
wait, 1 second, boys. There was an error in that question.
Oh, okay.
Here it is 10 centimeter, boys. This height is 0.1. It's not 0. It's 0.1 meter. Do you understand this question? Do you understand? I'm asking you, do you understand? What is it? You explain in your own words. What does the question mean? No problem. Sit and listen. Read the question. I'll try to figure out. Yeah. What happens? Okay. Okay.
Where it is 1.4, right? Because the answer will come as a root 2 if you take gravity as 10.
Yeah. M1 is a bullet which is moving with a speed of 400 meters per second. 400 meters per second hits a wooden block which is suspended. Now this is at rest. The wooden block is at rest. The bullet, right? So it transfers the momentum to the wooden block. The wooden block, which was initially at rest, now moves to a high pitch, right? So here, when the bullet strikes here, it will gain energy. So the energy will be high. When it goes to here, it's being released, it will have its potential energy. So almost the block takes the velocity of the bullet and then it has its own kinetic energy. So that kinetic energy will be transferred as potential energy. If there is no loss of energy, then the kinetic energy of the block will be the potential energy of the block. If there is no loss of energy. Is that clear? Copy down. So the kinetic energy of the block is half. Am I audible for the class also? Boys, am I audible?
Yes, ma'am.
I believe. Just check.
Ma'am, is there a formula to find like the potential energy of a spring balance or of a spring?
If for spring it is half kx square. For spring, it is half kx squared. K will be your spring constant, x will be your displacement. That is for your potential, elastic potential energy, boys. When you are talking about springs, that will be elastic potential energy. Now, when you are talking about a block being suspended, here you are talking about gravitational potential energy, boys. This is elastic potential energy. Now, in this case, this will be gravitational potential energy. That is why you are using potential energy as mgh. In case of springs, you use your potential energy as half kx squared.
Ma'am, what is K again?
K is spring constant. That is, K is your spring constant.
Okay.
Ma'am, how do you know that?
Yes.
Like it's a elastic collision for conservation of energy to be true?
See, when you are talking about elastic collision, it's only the conservation of kinetic energy. It's conservation of kinetic energy, boys. If the collision has to be elastic, it should be conservation of kinetic energy plus conservation of momentum.
Okay, ma'am.
So your block will be at a height of 0.1 meter with respect to its previous position, the rest position. Please understand all these numericals which are based on conservation of mechanical energy, because these are the topics which will be often checked even in your, say when you appear for your entrance examination. You can expect questions based on this. Kinetic to potential, potential to kinetic. So 2GH, the mass of the block is 2 kilograms. So anyway, the mass of the block will get cancelled here. So it is V is equal to root of 2GH. H is 0.1 meter. System of particles. Again, needless to repeat, very, very tough chapter, boys. From 11th standard point of view, it will be tough.
Ma'am, the answer is 1.4.
Yeah, meter per second. So might be tedious. The next chapter is the only chapter which will be tedious for you in the entire 11th grade. After the next tough chapter will be waves and oscillation. Anyway, we have to proceed. I'll start with that. Okay, shall I go first?
Ma'am, this will be the velocity of the block, right? The
Oh,
velocity gained by
block,
the
yes, yes. Yeah, V is the velocity gained by the block.
Ma'am, so that will be the same as the speed of the bullet when it emerges out.
Correct.
Okay,
So I'll go for the next one. Right, boys. Next, chapter 7. Chapter 7, System of Particles and Rotational Motion. System of particles and rotational motion. Next chapter, System of Particles and Rotational Motion. In this chapter, initially, what are you going to learn? You will be learning about what is meant by a rigid body. So far, how do you learn about all these motion? How do you consider your motion of? Is that you are studying about motion of a body or a particle? How did you learn was all the previous chapter? What was your concept? On what basis did you learn your concept? Did you consider culmination of particle or a single particle? I don't have an idea.
Ma'am, a single particle?
Yes, sir. You studied about, suppose you consider a body, suppose I am talking about a freely falling body, right? A freely falling body. You considered a body of mass m being dropped from a height. Here, you considered it as a single particle. We call this as a single particle, but this chapter you will be studying about system of particles. The system of particles, if you compare with your chemistry, HCl, a molecule, right? H plus Cl minus, right? Now, what we consider as H plus as H plus as a particle, Cl minus as a particle. Together, HCl, hydrogen chloride molecule will be considered as a two-particle system. Is that clear? So far, what you have learned is a single particle system. You started from the chapter motion in a straight line, motion in a plane, or laws of motion. Everywhere you considered as an object, right? Where you have a specific, you can specify the position of the object. You considered the object or a body as a single particle. Now you will be studying about system of particles. System of particles. Imagine hydrogen chloride, H plus and Cl minus, ionic bond. H plus and Cl minus are separated by a certain distance. H plus is taken as a particle, Cl minus is taken as a particle. So HCl molecule will be considered as a two particle system. What about H2O? Just H2O was. Yeah. H, and you know it has an angle. Is it a linear molecule? It's not a linear molecule. Carbon dioxide.
Ma'am, are you showing
Carbon
something on the
dioxide.
screen?
Yes. You can't
Ma'am,
hear?
Ma'am, are you showing something on the screen?
You can't see?
No, ma'am, we can't see anything.
No, you're not sharing.
Okay, one second. CO2, is it a linear molecule? Is it a
Yes.
linear molecule? Boys, can you see the slide? Boys, can you see the slides?
No, ma'am.
No, ma'am.
Can you see the slides?
Yes, ma'am.
Carbon dioxide is a linear molecule. It's a linear molecule, right? So carbon dioxide, you have 2 oxygen and 1 carbon. So that constitutes a
Ma'am.
3-particle system. Yes.
Can you show the first slide?
And was now in this chapter you will be studying about what is meant by a rigid body, then what are the different types of motion a rigid body can undergo, then what do you mean by center of mass. Now how to locate center of mass of a 2-particle system. Suppose if I have HCl, right? H plus and Cl minus, this will be considered as one particle. Cl will be considered as another particle, right? Now the mass of, this is a system. The system has 2 particles. This is the basic system which has 2 particles separated by certain distance. Where will be the center of mass is going to lie, right? For the 2-particle system, you are going to go for locating the center of mass of a 2-particle system, of a 3-particle system, and as well as n-particle system. So this is what you are going to learn. Now, definition of a particle is a point mass at some position in space. I'll have to use a different. Okay. Suppose if I have a particle, right, moving along xy plane. If I have a particle, say it has a mass m, its position is p. A particle is a point mass at some position in space. Its position in space, I'm just talking about xy plane. If it is in space, its position will be given by the x, y, and z coordinate. This is what we have learned about dealing with bodies or objects. All bodies have, as well as all the objects. What you have dealt in the previous chapter was dealt as a point mass. So a particle is a point mass at some position in space. It can move about, but no characteristic orientation or rotational inertia. Can this particle rotate? Can this particle rotate?
Ma'am, it's a point.
See, if it has to rotate, it has to have what? Axis of rotation. Okay, that's anyway. I think lower grades you have not learned about axis of rotation. Nothing. You have learned about axis of rotation? No. And we'll start with axis of rotation later. So a definition of a particle will be considered as a single point mass. It will have a position. If it is moving in space, its position can be specified by x, y, and z coordinates. I'll come to rotational inertia later on. System of particles or extended body. Now you're learning about what we call it as extended body. But suppose, for example, when you're looking at this object, right, your tube light, the same object, if it is far away, how do you look at this object when it is far away? How do you look at this object? The same object, say you are far away, say from there you are looking at this object. How does this object looks like? A point-sized object. Is that not? The same object, when it is far away, for you it looks like a point-sized object. When you're very near to this object, you can see the dimension of the object. Now here we call this as an extended object. There it is called as, when you're viewing the same object somewhere far away, it looks like a point-sized object. Here it looks like an extended object. So that is the difference. Have you learned about atmospheric refraction, twinkling of stars? Twinkling of stars. Why do planets don't, they are not going to twinkle? What is the reason? What is the reason, guys? You learned in grade 10. Why planets don't, why planets?
The apparent change in pulses.
You have done, you people have done, right? Atmospheric refraction.
Yes, ma'am.
So yes, you know the twinkling effect of stars, but have you learned about planets? Why planets do not twinkle? Because stars are far away. They look like a point-sized object. Whereas your planets are closer to you, it looks like a collection of point-sized objects. So the effect of one particle will nullify the effect of the other particle, so that you will not have the twinkling effect. There is a difference between a star and a planet. Star is far away, so it looks like a point-sized object. Planet is very closer to you in comparison to stars. So planet looks like a culmination of point-sized object. That such objects we call them bodies. Such bodies we call them as extended bodies. Boys, once again I am repeating, this chapter initially will be very tough for all the 11th graders. So just keep understanding it, boys. A system of particles, we call it as an extended body. Can you see here the system? Look at the system. What does the system comprises of? It comprises of, how many objects can you see? You can see a particle of mass m1. You can see another particle of mass m2, m3, m4, and mn. Mn is the nth particle. Is that clear, boys? So from the origin, you have a particle of mass m1 located at a distance of rn, r1 from the origin. Then you have another particle of mass m2 located at a distance of r2 from the origin. So with respect to origin, right, these particles are located at certain distance. M1 is at a distance of R1, M2 is at a distance of R2, M3 should be at a distance of R3. Then finally Mn, it has n number of particles. So this is a system of n particles. This entire thing becomes a system of particles. I can represent this as an extended body. Extended body will have a number of particles. Now each particle will be at different position with respect to your origin. Origin is very important. So you have an extended body. What is an extended body? Extended body is a collection of point-sized particles or point-sized object. An extended body is always a collection of point-sized objects or point-sized particles. We'll take it as particle here, right? So you have an extended body. This extended body has n number of particles. There's n number of particles. Now, the mass of each particles are different. Right? So M1, not necessarily it should be equal, it can be different also. So all these particles have different masses and they are located at different position with respect to the origin. Is this clear for an extended body? 11B? 11th standard?
Yes, ma'am. Yes, ma'am.
Yes,
No,
ma'am.
no, okay, fine. Boss, I'm moving a bit slow. Please understand. What do you mean by extended body? Extended body is a collection of point-sized particles. Now, each particle might have same mass or they can have different masses. Now, each particle will be located at different points with respect to the origin. This is what we call it as an extended body. Now we'll have to define what do you mean by a rigid body. Is that clear? Now look at this. Rigid body is an extended object or an extended body whose size and shape does not change as it moves. Now, what do you mean by that? What do you mean by that? Now, this is an extended body. Now, this body can be taken as a rigid body when I will consider this extended body as a rigid body. The question is, a rigid body is an extended body, but with a specific condition. Now, when this extended body is going to move, right? When this extended, you apply a force, you apply a force on this extended body. When you are applying a force on this extended body, the body begins to move, right? Say it's a linear motion. So when the body begins to move, then M1 also will move with certain speed, M4 will move with certain speed, and then all these particles will move with certain speed, but the distance of these body with respect to the origin will remain the same. Now, if the distance of M1 is going to change, now what happens to the shape of the body? Do you understand? Because this is an extended body, and I'm applying a force on this extended body, right? The condition is that M1, the distance between M1 and the origin. What is the distance between M1 and the origin? R1.
R1.
Okay. The distance between M2 and the origin is R2. So when the body begins to move along a straight line path or a curvilinear path, the distance of M1 from origin will always remains the same. M2 from origin will always remain the same. Mn from the origin will always remain the same. Now, if this is the condition, will there be any change in the shape of the body? Now, suppose if M1, when the body is moving, if this distance R1, right? If this distance R1 is going to increase, what will happen to the shape of the body? The shape of the body will change. Is that clear, boys? So a rigid body is one, right? When it is subjected to a force, each and every particle will be at the same distance from the origin or from each other. The position of the particle is not going to change. If that is the case, then such extended body, we call them as a rigid body. So when a rigid body is subjected to a force, each and every particle will be in motion, rectilinear motion, but their position with respect to the origin will always remain the same.
Ma'am,
Right? Yes.
I'm
what do you
extended.
mean by
Yes.
what do you mean by center of mass?
No, I haven't come to center of mass.
Oh, okay, ma'am.
Ma'am,
Right, boys.
extended body is a collection of point masses.
Yeah. Extended body is a collection of point masses. When this extended body is undergoing, was only this definition, which I am underlining, when this extended body is under an action of a force, when this extended body begins to move, if the position of the particles are not going to change, then such extended body, we call it as a rigid body, because the shape will not change, the shape or the dimensions of the object will not change. Why should I explain this once again? Should I
Ma'am,
explain
No,
this?
ma'am.
if none of the positions of each particle is changing from the origin, then how are they moving, ma'am?
Why not we can move?
No, the whole object collectively moves, but the orientation, no, like the
Yeah,
position of a
Ma'am,
particle
I
with
think the
respect to the
distance
origin
from the
changes.
each
origin
particle
will
will
change.
move. Each particle will move with different velocities, or if it is a rectilinear motion, each particle will move with the same velocity. Each particle will move with the same velocity, but the thing is that they will not be at different position. Their positions will not change.
Ma'am,
Yes.
like if the whole body moves, then the like distance
Okay,
from
one
the
second,
origin also
If this,
changes.
1 second, boys. If this is difficult for you, can you see this? A body is sliding down an inclined plane. A body is sliding down an inclined plane without slipping. They have mentioned only two particles, P1 and P2. Right? See, at any point, P1 and P2 of the block moves with the same velocity. When they move with the same velocity, they will be at equidistant from each other. When they move with the same velocity, what happens if P2 moves faster than P1? Will not the shape of the body changes?
Yes,
If
ma'am.
P2 is going to move faster than P1, then the shape of the body will change. So again, a rigid body. In a rigid body, when a rigid body undergoes a translational motion, rotation will be different. When a rigid body undergoes a translational motion, each and every particle will move with the same velocity. Yes, no voice. Each and every particle, if P2 moves faster than P1, after some time, P2 will be somewhere over here. This is P1. Will not the shape of the body change? Body will shape of the body will change. So that is a condition of a rigid body. Yes.
Translation
Yes.
motion. What is translation motion?
Translation motion is motion along a straight line, moving from one point to the other point. That is translation. It can be curvilinear also. Moving from one point to another point is translational motion. That can be a straight line path or a curvilinear path. So keep this in mind. So what is a rigid body? A rigid body is that each and every particle, rigid body is an extended body. So what is an extended body? It is a collection of n number of particles. So when a rigid body is in motion, each and every particle of the body will move with the same velocity, and the distance between any two particles will be the same. You can write in your own words, write it in your own words. So what is a rigid body? A rigid body is an extended body. Now what do you mean by an extended body? Extended body is a collection of point-sized particles. So what is a rigid body? Write in your own words. A rigid body is an extended body which is a collection of point-sized particles Next line. When a rigid body undergoes translatory motion, first point is each particle move with the same velocity. Then distance between particles will not change. Third one is that the dimension or the shape of the body will not change. So when a rigid body undergoes a motion, or when the body will undergo a motion when it is subjected to a force, so the shape of the body will not change.
Ma'am, these all points you have to write under what kind of motion can a rigid body have?
Undergoes translatory motion. Translatory motion means moving from one point to the other point. So when a body has to move from one point to the other point, it can be a straight line path or it can be a curvilinear path. Now we'll see a rigid body can undergo a rotational motion. Suppose instead of this wooden block, any block, if I'm placing a spherical object, a sphere, now what happens when I place a sphere on an inclined plane? What are the two types of motion I can observe when I place a sphere? Suppose I'm placing a sphere on the top of an inclined plane. What type of motion can I observe? Okay, rotational. Then sliding translatory motion. It keeps moving. It moves from one point to the other point. So when a sphere is rolling down an inclined plane without slipping, two types of motion you can see. One is translatory motion. The other one will be rotational motion. No need to write all these things, boys. Just everything is in text. Nobody will check you with this concept. This is only for you to understand what do you mean by a rigid body. Is that clear, boys? So when a rigid body undergoes only a translatory motion, each and every particle will move with the same speed. The distance between any two particles will remain the same. The shape of the body will not change. But look, when it is undergoing a, when it's sliding down, rolling down an inclined plane, for rotational motion, each and every particle will undergo different velocity, right? Each and every particle will move with different velocity. Look at the particle. What can you say about, what can you state about the velocity of particle T3? 0, right? Momentarily it will be at 0. So this is the point where the particle will be momentarily at 0. P1 will move with a different velocity, P2 will move with a different velocity. So each and every particle will move with a different velocity. When you are considering about the rotational motion, the body is rotating. For any rotational motion, now onwards you should understand there is an axis of rotation. What is the right? You know what is the axis of rotation? It can be a plane, rotational plane or an axis which is perpendicular. So about this axis, the body is rotating. So now when you study about rotational motion, you should know the axis of rotation. Some bodies will have only one axis of rotation. Some bodies will have many axes of rotation. We call this as a precessional motion. Whether you're the spinning top, and the top spins, it has different axes of rotation. One important application of precessional motion is what we use an instrument in your aeroplanes. Have you heard about, I don't know, gyrometers? Yes?
Ma'am, your voice is breaking.
Sorry, what?
Yes,
No,
ma'am. From the perpendicular thing you said. From
so
there.
whenever when the flight is in motion, if you want to check whether the flight is in equilibrium or not, they use an instrument. That instrument is based on precessional motion. If you have time, just check that, boys. All your flights, aeroplanes, when they are in motion, if they want to check at every point, they'll check whether the the air flight is in balance or not. To check the balance of your air flight, they use one special instrument which is based on precessional motion. Anyway, I will do the precessional motion later on. It's only the introductory part. Still, we haven't started the chapter, boys. It's only the introductory part. You should know what is a rigid body. Here. So now, when a rigid body undergoes a translatory motion, each and every particle will move with the same speed. But when it undergoes a rotational motion, the distance between the particles will not change. If the distance changes, the shape will change. But what happens is that each and every particle will move with different speed. That is the difference over here. So as it is rolling down, even if it rolls down an inclined plane or even if it's rolling on a plain ground, right? It has both translatory motion because it's moving from one point to another point. At the same time, it is going to rotate. It's going to rotate about an axis. So whenever a body rotates, it always rotates about an axis. Can you see the axis of rotation? Now you should be familiar with all your axis of rotation. I think when the fan rotates, the blades are going to rotate about an axis.
What is the difference between translation and pure translation?
What is the difference between?
Translational motion and pure translation motion.
In that case, boys, you have a translatory motion. The path can be different. It can be a straight line path. It can be a curvilinear path.
Yes, ma'am.
Yes. Now this is one example of rotational motion where you have a particle P1, P2. Now P1, P2, please understand. In case of your extended body, it's a tough chapter. I do understand. But when we started with this
Ma'am?
extended body, yes.
Now, was there anything to write in the previous
No,
slide?
no, no, nothing.
Oh,
I've
okay.
just to introduce the chapter. I have just introduced the chapter. Boys, when we started with a rigid body, right, or an extended body, you consider the position of M1, M2, and Mn particles with respect to the origin. This is for in case of a translatory motion. When the body is rotating, suppose this is a rotational motion. Now here, you are not going to consider the origin, you are going to consider how far the particles are from the axis of rotation. That is not the axis of rotation. This is your axis of rotation. That clear, boys? When you are considering the motion of a rigid body, translatory motion, you are considering the position of each and every particle with respect to the origin. Right? Here, when you are talking about the rotational motion, this entire body is rotating about an axis. So then, how far is your particle P1 from the axis of rotation? How far is your particle P2 from the axis of rotation? Now you will be studying about two types of motion. One is this, each and every particle, P1, P2, they have linear velocity. This will be your linear velocity. You understand? When the body, now I'm just taking a single particle. When a particle is rotating about an axis of rotation, it has a linear velocity. At the same time, it's going to rotate with angular velocity omega. So whenever a particle or a body undergoes a rotational motion about an axis, it has both linear velocity, it has an angular velocity. Right? Here, when the body is rotating, extended body is rotating, each particle will be at a certain distance. Here, R1 is from the axis of rotation. R2 is the distance of particle P2 from the axis of rotation, not from the origin. Because I think so. Anyway, these are all there in the textbook. One added information is about precessional motion. Here, we have only one axis of rotation, a single axis of rotation. But there are bodies like your spinning top. Have you seen the top spinning? It will have various axes of rotation. This is what we call as precessional motion. Same way the precessional motion for Earth, as well as one important application is if you have time, just go for it. We call this gyroscopes. Different people pronounce it.
Ma'am?
Yes, I'm not
ma'am,
audible.
please.
Okay, you can start your match. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, a doubt? Yeah, ma'am left. Wow. Bye.